Hi there, my name is Marcus Hellberg, and in this video I'm going to show you how easy it is to build a progressive web application. To do that, I'm going to first build a very simple newsreader application from scratch, and once we have it up and running, I'm going to take that and turn it into a progressive web application step by step, just so you can see hands-on what the different steps are that are involved in building a progressive web application. So let's start. We're going to create a new folder here on my desktop, call it News. Let's go into that folder, and in here open up our code editor of choice. I'm going to use VS Code, and of course you can use whatever editor you're most comfortable with. In here we're going to scaffold out the project, so let's create all the files that we need. We're going to need an index file. Let's just populate the file with just a blank template. Give it a title of News. Here we can just scaffold out the basic layout of the application. So we're going to have a header section, and here we're going to have a h1 tag just for the title of our application, and then we'll have a main section where we'll actually populate all the news articles. In addition to that, we'll have a style sheet. So we'll just have a link here and just styles.css, and we'll also include a JavaScript file for all the application logic. Let's call it app.js. Then let's go ahead and create these files. Styles.css. Here I just have a ready-made template for the styles because we're not going to focus on the actual styling. Then we'll have the app.js file. We can leave it empty for now and go ahead and serve this folder just so we can see that we are on the right track. Let's serve this, close the console here, and hop on over to Chrome. Okay, so you can see that we have the application is up and running. Here in my Chrome DevTools, I am on the Application tab. This Application tab will be your best friend when you are developing and debugging progressive web applications. So in here we can see all the different parts of a progressive web app. Like we can see the manifest file if we had one. We can inspect service worker, it says they're running. We can go in and clear all the data, so it's easy for us to just reset everything and start from scratch. And we can also just jump in and debug things as we're working on this. Okay. So the first thing that we're going to do is just build the plain non-progressive web application. For the news itself, I will use a free news REST API called newsapi.org, and we're just going to use it to fetch some articles from different sources and display them. Let's copy this URL here and go into our app.js file. So the first thing I'm going to do is add a event listener for the load event. So I don't want to block the initial load of the page with this REST call. I just want to have the initial HTML display as fast as possible, and once it's done, then we can start actually fetching data. So in here we're going to call a method called update news and create it here below. Like so. Here I'm using async functions, and if you're not familiar with them, I'll add a link in the notes below, but basically they just make it easier for us to deal with promises in a much more readable fashion. So be sure to read up on them if you're not familiar. I'm going to use them throughout the example here. So for the update news function, the first thing that we're going to do is get the result, or the response rather, from fetching this URL. And of course my API key is different from this, so let's extract that into a variable, and I'll define it up here. Just log in to the site and get my key real quick. There we go. Like so. Alright, so once we have the result, we want to actually get the JSON that's in that result. So what we're going to do is, again, await and then result.json. If we go back into the documentation here, for articles, we can see that the response looks like this. So we get an object, it has a array of articles, and then each article has a field for things like author, title, description, image, and so on. So let's go in here, and what I'm going to do is a little bit of a hack, but I don't want to use any frameworks or any other tools, just plain vanilla JavaScript here. So what we'll do is just first of all get a hold of the main section where we want to put these. So we're going to do a document query selector for the main section, and here when we're updating the news, what we're going to do is just say main.innerHTML equals, and then we're going to go through the JSON and the articles in there and map them through a function that creates an article, and then just join those articles with a new line to make them a little bit more legible in our HTML. Let's create the create article function here. It takes in the article JSON and spits out the actual markup. So here I'm just returning a template string that has the stuff that we need out of the article. So we have the URL, we have the title, we have an image, and the actual description for it. Let's save this, go back to our browser here and refresh. And we can see that with that in place, we're now able to actually see some articles in our app here. One thing that we still want to do in order to kind of complete the functionality of the application is add a little selector here where we can select which source we want to get our news from. The API here has another endpoint that we can call for that, just sources. So let's go ahead and do that. So we'll both update the news, update the sources. Again, create a new async function for this. Update sources. And here we're going to do pretty much exactly the same thing that we did for the news. So we're going to get the result from fetching the sources. Then we're going to get the JSON from that result. And if we go in and look at the actual response here, we can see that again we get an object and it has an array of sources. So what we want to do is just loop through those sources and populate our selector. Now, of course, we need a selector for that, so let's just create a new select. We don't need a name for it for this particular stuff. What we do want is to give it an ID. Let's call it source selector. And here in our app, again, let's just get a handle to it. Selector equal query selector for selector, like that. So what we want to do here is just get the source selector.innerHTML equal to JSON.map, and then we're going to just map each of those sources, actually json.sources.map. So we go through the sources array, we map those to options, and we can just, again, join them with new lines just for easier reading if we need to go in and inspect the actual markup later on. Okay, so let's go into our browser, refresh here, see if that works. Now that did not work. What did I do wrong? Source selector. Oh, a little typo there. Selector like that. Save both of those. Go back in the browser. refresh, and we can see that we have the different sources here. There's a couple of problems here. First of all, you can see that these are not in sync now, so the selector's first item is ABC News for Australia, but we're displaying TechCrunch. So let's go and change that behavior. First of all, let's change the default source for our news, and then we'll make sure that those two stay in sync. So if we select another source, we want to fetch the news from that source. So let's define our default source. I'm going to call this default source the Washington Post. Post, like that. And then instead of just updating news always to fetch from TechCrunch, what I'm going to define is a parameter source, and we can default that to default source, and then just change this hard-coded source here to our parameter, like so. All right, and what I'm going to do then is just await for the update sources to complete. So we need to turn this into a async function for that to work. And once we've actually fetched the sources, then we can set the source selector's value to equal our default source. Again, let's go into the browser, refresh. Okay, so now we can see that this actually matches. So we have the news from the Washington Post, and we see that Washington Post is selected. The final little thing that we need to do here is have a listener for the select change, and then actually fetch the news based on that. So let's do source selector that event listener for the change event. And what we want to do here is very simply just call update news with event.target.value. Just get the value out of the select and call update news with that. Let's refresh here, try it out, select this. Yep, so we can see that we can now select different sources for our news and get them displayed. So we have the basic functionality of our application. There's still nothing progressive about this web application, but at least we have a very good understanding of how it works, where it fetches its data from, and so on. Okay, so let's start looking at turning this application into a progressive web application. Now if we go in and look at the application tab here in Chrome, we can see that the first kind of sub-tab here is manifest. And the web manifest is really just a JSON file that collects all the information about your application into one convenient JSON file. So this is basically the same information that you have in all those different meta tags in your browser, or I'm sorry, in your application header today. So instead of typing this out myself, I'm going to use a web app manifest generator that I found, and we can just define the application name. News, we can give it a short name, so if we had a really long name that wouldn't fit underneath the icon when this gets installed, we can give a shorter name that would be used in place of that. We can define the colors that we want our application to use. We can define how it should be displayed. In our case, we want it to be standalone, so kind of hide the browser, Chrome, and everything. And then I just want it to start from whatever URL the person was on when they browsed to this application. Final thing we need is an icon, and I can just drag my icon file here. You need to upload at least a 512 by 512 image for this to work. We generate the zip file here, open it, and what we'll just do here is take these two, drag them into our application folder, and then go back into our editor and see what we have. So there are two things. We have the manifest file here, so you can see we have this JSON file with the name and short name and the theme colors and URLs here. And then we have this image folder, which contains all of these resized images that we need. Using the manifest file is really easy. The only thing we need to do is just add a link to it. So the only thing we need to do is add a link to it. And if we go back into our browser, refresh this, we can see that now the application tab here picks up our manifest. We can see all of those parameters that we define. We can see the icons and everything. Now if we click on add to home screen here, it's going to complain that we don't have a matching service worker. So in addition to having this manifest file, you also need to have a service worker installed for the application in order for it to actually get picked up as a progressive web application by devices and for them to offer to install this. So let's go ahead and create a service worker. Now service worker is just basically a normal JavaScript file. It's kind of like a web worker in that it doesn't run in the same kind of thread as your main application, rather it's just separate. But it is just a plain JavaScript file where that you program in JavaScript. The way we include this is by, first of all, making sure that we have support for it. So we want to make sure that we have service worker in our navigator object. Now if we do, what we want to do is first of all do a little try catch here. So we want to first of all try and see if we can do navigator.serviceworker.register and pass in our service worker file. Here we want to be careful about with the path of this file. So in order for a service worker to handle the traffic, it needs to be in the root of your application. So it can only handle things that are in the same folder or child folders of where the actual JavaScript file is. So make sure that you have it in the root of your application. Once that's done, we can just do a quick log, say service worker registered, and of course if this fails we'll just log out registration failed. Go into our application again, refresh, and we can see that our service worker did actually get registered. If we go into the service worker tab here, we can see that the service worker file is registered right here. We can click in and see the contents of it. Obviously there's nothing in there right now, but that's a good start. So let's go into our service worker file and take a look at it. The service worker is completely event driven. That means it can't just run stuff by itself because it feels like running a whole bunch of computation. Rather, it can only get triggered by events. So there are a couple of events that we want to listen for in this demo. The first one is the install event. So we'll just add an event listener for the install event. And here we can just log out install. Then we'll do the same for the fetch event. The fetch event is basically when the service worker intercepts any network request going out from your application to the net. So we'll just do a self.add event listener fetch, and then we'll just log out fetch so we can see what's going on. So we save that, we go back into our application, and we refresh. Now what you see here is that we have, if we click on the active service worker, we see it's still the empty one, and we have this new service worker here waiting to activate. So by default, when you've registered a service worker, it will continue to serve all the requests for that specific domain. So in order for the next or the new version to actually take effect, you either need to close all the tabs or you can kind of skip that by pressing skip waiting here. Now every time you make any change to your service worker, the browser will detect that as a new service worker, and especially during development time this will get pretty cumbersome. So I recommend that you check this update on reload, which will make sure that the new changes will always get included when you're running the application. So if we refresh this now, you can see that we got the newest changes applied here. Okay, So we have our service worker file, but it's not really doing anything yet. What we want this service worker to do is, first of all, cache all the static assets that we have in our application so that we can serve them from the cache and get a really fast startup time for our application, and also make sure that we can at least display something when a user is offline. So let's define a array of static assets. And here we're just going to define the different assets that we have. So those are the exact same ones that we created in the beginning. So we'll have the root of our application, we have the styles.css file, and we have the app.js file. I'm using relative paths here just because I want to run this from my GitHub pages, and if I'm not in the root of the domain, having this relative path will make that work. So with those defined, we can actually start using our service worker for something interesting. Now here in the install event, this will get called when a new service worker is discovered and it gets installed. So what we want to do is use the cache API to take all of our static assets and save them for later. The way we do that is, first of all, get a handle of the cache. We do that by awaiting caches.open, and then we have a name for our caches, so let's call this new static. For await to work, of course, this needs to be an async function, like that. Once we have the cache here, we can just say cache.addAll and pass in our static assets. Save this and go to our browser. Now if we refresh here, you can see that the cache tab here has a new kind of child node, and we can see that it did actually cache all of these files that we told it to do. Now if we go to our service worker tab again and simulate an offline situation and refresh, of course this doesn't work still. So we did cache all of those assets. We can see that they are in our cache, but despite that we can't really do anything with them unless we instruct it to. So the service worker is a really low-level API. It doesn't really do anything unless you tell it that it needs to do that. So let's tell it what it needs to do. First of all, here when we're intercepting fetch events, these are the events sent from our application to the network. Let's first of all pull the request out of the event object here, like so. And what we can do in a service worker is we can define how we want to respond to a given fetch event. So we can call event.respond with, and then we can define how we want to respond with it. So for our static assets here, we want to respond with the cached assets first, and if we don't have anything in the cache, we can go ahead and try and fetch them from the network. So let's call this a cache first strategy. So we'll just pass in our request and then create our function for handling that. So we'll async function called cache first, and it will take in this request. Now here we first want to check if we have a cached response. And we do that by calling caches.match with the request. So the request itself is the key in the cache. Now this will return either undefined if there's nothing in the cache, or with the cached response. So we can then go ahead and return either the cache response, or if there's none, then we can call fetch with that request. So that way we fall back on the network. Let's save that, go back into our browser, refresh, check our service worker file, just make sure everything got picked up so we can see we actually have all the new code here, which is good. We can check our cache storage. We can see that we have everything in there. So if we go offline now, you can see that it doesn't give us the offline dinosaur. What we get instead is basically the application shell. So the shell of the application is the static part of the UI, the part of the UI that remains the same regardless of what content you're actually viewing. So it's already a little bit better. It's not really a progressive web application, or it is, but it's not really that helpful to our users. Instead, what we want it to do is actually save news as we're browsing through them, so that if we go offline, we can then come back and at least read the news that we've viewed previously. So let's refresh that and go in. So in order to do that, we're gonna have a different caching strategy. So for any of the news, we actually want to go to the network first and try to always get the latest news. And then if we're unable to do that, we'll fall back on the cached version for that same news source. So let's first of all get the URL out of the request. So create a new URL object with the request.url. And then if the URL's origin is equal to location.origin, so basically if we're fetching from our own site, then we'll use this cache first strategy. That's for the static assets. Else, we're gonna call event.respondWith and do a network first approach. Again, let's go and implement this here. So we'll have a async function called network first, and that again takes in the request. Here we're going to use a different cache just because I want to keep the dynamic assets separate from the static assets. Later on, it would make it easier for me to clear out some of the dynamic assets as they get old. So let's call this cache, and again we're going to wait caches.open and get a new cache called news dynamic. We'll then do a try catch, and what we're going to try to do is go to the network and fetch news. So we're going to await the result of fetching the request. If that worked, we're going to first of all store the request into our cache so we can fall back on it later. We do that by just calling cache.put. So instead of cache.add that we used earlier here, we're going to use put. This allows us to actually define the request using add would go and refetch it, which is unnecessary in this case. So we're going to put the request there as the key, and then we'll do response.clone for the actual content. So we're going to clone the actual result here because it can only be read once. So if we put the actual response in there, we wouldn't be able to return it to the browser. Okay, so that's kind of if everything goes well, and if things don't go well, we'll just go. Sorry, we're gonna of course await this and await cache.match with the request. So we're gonna try to go to the network, put it into the cache. If that fails, if we're offline, we're gonna try to see if we have something in the cache and return that instead. So again, go to our browser, refresh this. We can see now that we have two caches. We have the dynamic cache and the static cache. We can see that we have all kinds of different, we have the JSON files here from our REST APIs, we have images and so on. So if we go to our service worker tab again, refresh, we can see that this now works. So we are offline, but we're able to browse the news articles that we had seen before. Now if we go to another source, it doesn't work because we haven't been there before, but as long as we keep kind of browsing these different articles, we're able to kind of see those when we are offline. Now it would be nice if we could have some sort of fallback content, so if I go to USA Today and I haven't been there, it would show us at least some sort of meaningful content and explain what's going on. So let's do that. So here I have a couple of files on my desktop. First of all, a fallback JSON response, so that's something that I'm going to respond with if we don't get something from the network or the cache. And then I have a fallback image as well. First thing we're going to do is cache those so we have them available to us if we are offline and we're unable to return anything meaningful to the user. So we're going to do the fallback.json and also images fetch dog.jpg. So what we need to do then is change the kind of cache behavior here. So instead of just returning whatever we have in the cache, which may be undefined, we're going to save that into a cached response object, and then very similarly to what we did here, in our cache first response, we will either return the cached response or we'll go to the main caches and match on fallback.json. The fallback.json here is just a JSON file that follows the same format as the news response itself. So let's save that. Let's go into our browser. Again, refresh. Make sure that we have everything in here. We can see that the new service worker changes did get picked up. Go back into our application tab here. See that it works. Let's go offline. So we should be able to view the Washington Post since we've been there. And if we go to USA Today, we'll get our fallback content here. So with that, we basically have a pretty simple but working progressive web application. So with this simple service worker in place, we're able to have a progressive web application. But as you can see that even for this fairly limited amount of functionality, we already have quite a bit of code. Also, this is not a very robust production-ready solution, so there are already some things that you can probably notice that we're doing kind of wrong here. One of the things is that this dynamic cache here just keeps on growing and growing, so we don't have any way of just kind of purging out old content as it gets unuseful to us. We also don't have a way of updating single assets in our cache. So in a real-life situation, one of the nice things with progressive web applications is that if we only change, say, the app.js file, that's the only file that the browser needs to re-download. So especially when you're creating applications for places where you have low or very expensive, low speed or very expensive data connections, having the ability to just update specific assets in your application instead of having to go and re-download all of them like we are doing now is very helpful. So in order to solve kind of both of these problems and to give us a easier way to build production quality service workers, Google has this tool called Workbox. So let's rewrite the service worker that we have currently using Workbox and see how much we can kind of get rid of boilerplate with that. So we can go ahead and delete all of that code that we wrote and go into our command line here. I'm going to turn this into an npm project real quick, like so. Then going to install Workbox. It'll take just a couple of seconds here. And with that installed, let's first of all go and serve this again so we don't forget that. And what we can do is import the Workbox script. Just do import script. and pass in the path for Workbox. Here in the scripts we have two different ones. We have a development version and a production version. Let's copy the path to the development version. That gives us a little bit more help along the way when we're developing this. Go in and make sure that we don't need to have the full path here. Just a relative path will do, like so. Then we'll initialize our service worker, or workbox rather. So new workbox SW, and then we can just call pre-cache on that and pass in these static assets, the same ones that we had from before. So if we go to our browser here, let's go to application. Let's first of all clear everything, so we're starting from a clean slate. Let's refresh this. You can see that first of all we have a cache here called Workbox Pre-Caching Revisioned. You can see that we are getting some debug messages from Workbox, so we can see that it's up and running. If we go into our application here, go offline, we're able to refresh this and see that we're back to the state where we were showing the application shell. So that's already a lot less code than we had before. The second thing that we want to do is cache the calls to the news API. For that we can use the built-in router in Workbox. So we can just call workbox.router.registerRoute, and here we can pass in an express style route. And in our case, the route we're interested in is newsapi.org/anything. And when this route gets hit, what we want to do is call workbox.strategies.network first. So by just using one of the already defined strategies, network first here, we don't need to re-implement the logic for that. Now if we go back to our browser here, refresh this, we can see that we now have this runtime caching cache here as well that has the JSON for both the articles and the sources. So if we go and make ourselves go offline, we can see that we are getting the articles here, but the actual images are not showing up. But that's okay, because what I really want to do here is define a special route, or basically a special way of handling images. So I'm going to use the cache first strategy that it comes with, but I'm going to define some cache expiration parameters. So I want to keep a maximum of 20 entries, and I want to keep them for 12 hours at most. Here I'm also defining the status codes that I want to cache, so 0 to 200, basically 0 being those opaque responses. So let's save that, go back online, let's refresh this. We can see that we now have this images cache here, and if we start going through these different sources, you'll see that we're now starting to expire old entries from our cache. So this is a really great way for us to easily keep the size of our cache to a manageable size. We're not going to start consuming a lot of space on our end users' devices. So with that, we have again a working progressive web application, this time with a lot less code and with something that's going to be a lot easier for us to deal with. Workbox comes with a built-in command line tool, and also ways for you to call it from build tools like Gulp. So that's it for the video. I hope you learned a lot about progressive web apps, and I'll leave some links to further reading in the show notes below. Thanks for watching.